Uh, Glen Mattioli, I'm the Director of Geodetic Infrastructure at UNAVCO, and as part of that, I'm also the Plate Boundary Observatory Director, and I am also a Professor of Earth and Environmental Sciences at the University of Texas at Arlington. I got started in geodesy in 1994 by participating in a GPS campaign in the northeastern Caribbean called Canape. And originally I was basically involved in the technical or field aspects of the data acquisition. This was one of the first experiments that was funded by NASA and then subsequently by NSF to study the relative motion between the Caribbean plate and the North American plate. I do sometimes call myself a geodesist. It depends on the context. Sometimes I call myself a geodesist, sometimes I call myself a geophysicist, because most people don't really know what geodesy is. So it depends on whether I want to explain what geodesy is. And then other times I refer to myself more as a volcanologist, because a lot of the geodetic work I've done has been related to studying physical processes at volcanoes. 1994. It was the first time I was involved in doing it, and then I got significantly involved in, we wrote a proposal in 1994 to start doing geodesy throughout the Lesser Antilles as a baseline for understanding volcano unrest in the Lesser Antilles. And that proposal was funded in the spring of 1995, and then the Montserrat the Soufriere Hills volcano in Montserrat started erupting in June of 1995. So it was fortuitous, and I basically got started then, and that's what I've been doing ever since. Well, there were two things. When I first started, I thought I had read a paper by Alan Lindy, who's a research scientist at Carnegie Institution of Washington, and he had used a strain meter in Long Valley to actually study how bubbles propagated through magma at depth at Long Valley. And I was fascinated by this because I had studied, when I was a visiting associate at Caltech, I had studied bubble nucleation and growth and had done some experiments on this. So I thought this was really cool. So that was my first interest in how to apply it to volcanoes. And then subsequently, I learned that GPS really wasn't precise enough to look at that type of problem. So we basically used GPS to study bulk mass flux through the volcanic system and the geometry of the plumbing system at depth at Soufriere Hills. And then I was always interested in sort of plate kinematics and plate boundary interactions, but that's taken a lot longer to tease out because the relative motion between North America and the Caribbean plate, where I've spent most of my academic efforts, is very slow, unlike some other plate boundaries that see frequent large earthquakes. Well, I think the UNAVCO facility has done a great job helping us define plate boundary deformation in general throughout the globe. So initially a lot of that work was done through campaigns by various PIs at different academic institutions. Some have lots of projects across the globe. Others have been more focused regionally. So just understanding how plates are not really rigid, especially when you get close to their boundaries, is something that UNAVCO has contributed to greatly. I think that we've also contributed to setting the standard for open data policies and allowing the global community to see that you can gain a lot of value by providing open data, even if it's somewhat latent to the community. And lastly, just being able to share resources. GPS receivers initially, even in the early 90s, were still pretty expensive. So being able to share resources and allow us to share expertise, because our engineering staff are extremely expert at a lot of the fine details associated with how to use this equipment properly. So I think we've done a lot in those three areas. Well, I think the major technical advances were we've driven the receiver manufacturers to provide receivers that are more easily accessible and allow us to program multiple different sessions so that they can serve different communities, so we can get high rate data, we can get data that's taken at lower frequency. We've convinced them to build interfaces to allow us to put other sensors at the sites. The other technical advances that we've done are related to monumentation. Some of this was built on work that had been done basically in the SIGN network, the Southern California Integrated GPS Network. But we modified some of their designs and improved on those designs. And the last one, I think, has been development of long-running remote power systems, in particular in polar regions, where we've been able to keep these stations up through the polar winters, which is really an amazing feat. And those data are very critical to a wide range of important science problems in the polar regions. Well, from my perspective, when I first started I wasn't there at the beginning of Geodesy. So my background was more in experimental science, and the things that really changed since I've been paying close attention was the incredible technology of interferometric synthetic aperture radar, which really allowed us to get synoptic views of ground deformation, in particular related to coseismic displacements. That's one thing that really changed over the last 30 years. The other thing that I see changing, and has changed pretty significantly, is we used to do a lot of campaign work. So individual PIs used to go out and work with a team, and I really mean a team. We used to have a lot of people that had to be in the field together to collect data, distributed over some area. And now what we've done is we've put out a lot of stations that are operating in continuous or semi-continuous mode, and we're learning a lot from those types of observations, because we didn't know that there were going to be signals at different time scales, and those are becoming evident because we have lots of continuous data. And the other big change I see is now there's a number of global processing centers, or even if there were always global processing centers related to defining the orbits and the frame and the clocks and things like that. But now there's several research groups that are processing thousands, if not close to 10,000 stations on any given day. So that's really a big change. People used to work on their own little projects, and that's, I think, a significant change as well. So the last thing I would consider as a trend, but we haven't really fully realized it, is this concept of federating resources together so that we can share across national boundaries, and because the problems, of course, the geophysical problems extend beyond simple national boundaries. Well, my only other comment would be that I think it's been terrific working at UNAVCO for the last more than a year and a half. I've gotten to learn a lot more about how UNAVCO operates. I've gotten to meet a lot more community members as a result of that, and interacted with our governance committees quite extensively over that period of time. So that's about the only thing I would add. So I've learned a lot more about what the potential is for UNAVCO going forward. Yeah, Geodesy is an incredibly powerful set of tools and techniques and sort of a worldview. And one thing that we need to improve on is we've done a great job with GPS, which works on the subaerial exposed parts of the globe. But as everybody knows, 3/4 of the globe is underwater. And we do a very good job of defining plate kinematics because we can use marine magnetic anomalies and things like that. But looking at plate boundary processes that are underwater, either at convergent margins, transcurrent margins, transform faults, or ridge crests, is just really inaccessible right now. The precision and the cost associated with doing that type of work is just prohibitive. So I see the future of geodesy in coming up with techniques that are going to allow us to get centimeter per year and approaching maybe millimeter per year in the next several decades from sites that are underwater. So that's, I think, the real future over the next 20 years is bringing the cost down and figuring out technologies that are going to allow us to do that appropriately.